Imagine a world so alien, so extreme, that the very idea of life seems impossible. In this world, the familiar is stripped away. There is no sunlight, no air to breathe, and no comfort of gentle temperatures. Instead, a timeless night reigns in every direction. The weight of mountains crushes every inch, the tiniest spaces brimming with deadly poisons, acid, salt, and relentless radiation. Heat seeps from the planet's formation, mixing with chemical dangers, as if the entire realm has been forged in the fires of hell. Yet here, in these unimaginable conditions, life not only survives, it thrives, teeming in numbers that boggle the mind, accomplishing feats undreamed of by living things on the surface. This is not some distant exoplanet light years away. It is Earth itself, specifically the deep biosphere, a hidden world that scientists have only just begun to discover. Stretching across twice the volume of all the world's oceans, it is home to more living things than anywhere else on the planet. Octillions of microbes, numbers so immense our imaginations fail, make this their kingdom, their fortress of survival. Their combined mass outweighs that of every human, cow, whale, bird, and beast we know by at least 20-fold. Welcome to the deep biosphere, a realm beneath our feet, ruled by creatures more fantastical than any science fiction. To understand this underworld, let's begin where life is lush and familiar. The soil. Crawl through the uppermost layer of Earth and you find a partnership of essential ingredients, air, water, minerals, and decaying matter, forming a rich, dynamic landscape where most plants and animals make their homes. Here, energy from the sun powers a dizzying bloom of life. Plants alone generate a living mass 30 times greater each year than all animal life combined. Some organic matter is buried deeper, creating the nutrient streams that sustain life even as it slowly creeps downward. But below this paradise, things change quickly. Air disappears, water creeps in, and the world becomes colder, darker, quieter. This is the region saturated with groundwater, a realm where only the hardiest roots dare reach, and life persists mostly as scavengers feeding on residues of surface decay. It's a cold reminder of ancient ice ages, sealed off from sunlight. Deeper still, we hit the bedrock, a realm so seemingly impenetrable that for millennia we imagined it a world without life. But the deep biosphere taught us otherwise. Bedrock is riddled with fractures, cracks, and microscopic pores, hidden chambers that, collectively, form a vast network of subterranean habitats. Even the densest rocks are not entirely solid. Up to 40% of the volume in rocks like sandstone and basalt may actually be empty space filled with water and, astonishingly, with life. Pressing deeper through the rock, temperatures rise. At just 400 meters below, the pressure equals the surface of Venus. Descend a kilometer, and the temperatures creep towards 30 degrees Celsius. Oxygen, even in trace amounts, is almost entirely absent. At nearly 4 kilometers down, where we find ourselves crushed beneath tens of thousands of tons of rock, temperatures soar past 100 degrees Celsius. The environment is not just hot, but toxic. Chemical salts, acidity, and radiation fill the dark. The heat seeps up from Earth's beginnings and from the decay of radioactive elements like uranium and thorium, bathing these rocky chambers in a constant, invisible storm of energy. And yet, almost miraculously, there is life. Not just life, extremes of life, pushing every boundary and redefining what we thought possible. These hidden chambers are microcosms, each harboring entire worlds of microbial beings, honed by eons of evolution to survive every deadly twist. In these crushing, acidic, radioactive depths, microbes dominate, octillions upon octillions, each hardier and stranger than the last. Some are fiercely independent, self-contained worlds unto themselves. Take Desulforudus audaxviator, a bacterium that gathers energy from the very minerals of the rock, synthesizing the barest necessities for life from carbon and sulfur. When conditions fail, it turns inward, sacrificing itself to form a tough, protective endospore that can survive for thousands, perhaps millions of years, waiting out doom until a new opportunity arises. Others are community-minded, forming complex webs to eke out survival together. Some cloak themselves in biofilms, thin shield-like nets where different microorganisms play different roles, each contributing to the survival of the group. One type might breathe methane, another will carry the leftover electrons, yet another will digest sulfate, each step creating energy or materials to support the next. Extremophile archaea, such as Altiarchaeum hamiconexum, cling together using nano-sized grappling hooks, creating fortified colonies in water-filled fissures where even hydrogen becomes a meal. The most profound feature of deep life is its sluggish, slow-burning strategy. With resources scarce, the metabolism of these microbes slows to a crawl, 1,000,000 times slower than surface dwellers. A single meal can sustain them for centuries. Some are believed to live for millennia, persisting in a kind of cold, suspended animation until fortunate chemistry or shifting rocks grant another brief chance at action. But the story does not end with microbes. Occasionally, using sensitive drills and by pure luck, scientists have discovered small multicellular predators, asexual worms, rotifers, even minute arthropods, outsized giants compared to their microbial prey, hunting in cracks kilometers below. Whether these fierce hunters evolved in the deep or were swept down via seismic cracks remains a mystery, but their existence signals a complexity and resilience far beyond what we imagined. Yet our knowledge of this vast, mysterious biosphere is painfully incomplete. Sampling these depths is daunting. Each drill risks contaminating pure samples with surface life. Bringing deep microbes to the lab is another challenge altogether. Recreating their crushing, boiling, chemical-laden worlds is almost impossible, and their unhurried pace makes observation almost a meditative exercise in patience. Much of what we know comes from studying their DNA, inferring their abilities from gene fragments, hints that some might breathe nitrogen, survive on metal ions, or feast on methane extracted from stone. Every whisper from below tells us how little we know. The diversity of life underground likely dwarfs that on the surface. New phyla, families, and forms may still wait in hiding. This uncharted territory holds promise for breakthroughs in medicine, new clean energy sources, and vital clues about Earth's climate and past. Perhaps most exciting is the question this discovery awakens. If our planet's crust holds such hidden abundance, beyond light, beyond air, beyond norms we held sacred, might other worlds be similarly alive beneath their barren facades? Could Mars, icy moons like Europa, or a dozen undiscovered planets also harbor deep biospheres, supported by nothing more than internal heat and a few basic chemicals? Each clue gathered from below our feet may point the way to answering the greatest question of all. Are we truly alone in the universe? Or are we only just now learning how to look for life, hidden and extraordinary, wherever worlds are found? Did you find our videos helpful? Please like and subscribe to our channel so we can be motivated to answer the questions that people are still wondering about.